Welcome to the LibertyCon panel, in which we will discuss disruptive space technologies. Our panel is composed of LibertyCon's science guest of honor, Art Dula, along with members of the Interstellar Research Group. Arthur M. Dula is a space lawyer, a patent attorney, the literary executor for legendary science fiction author Robert A. Heinlein, as well as chairman and founder of the private spaceflight company Excalibur Almaz. Doug Loss was an IT security analyst. Currently, he is serving as the IT chair and president of the board of directors for the Interstellar Research Group. Stephen Fleming is an investor in the alternative space industry and is a founding member of the Space Angels Network. He is the conference chair of the Interstellar Research Group's 2021 symposium in Tucson, Arizona. Les Johnson is a scientist, an author, and the NASA principal investigator for America's first interplanetary solar sail mission. In his free time, he writes science fiction and popular science books. Ken Roy is an engineer who works amid the relics of the Manhattan Project in Oak Ridge. He has published a number of technologically speculation pieces. His current interests include terraforming and geoengineering. Dr. Joseph Meany is a chemist and material scientist. His first book, co-authored with Les Johnson, is called Graphene, the super strong, super thin, and super versatile material that will revolutionize the world. Jeff Greason is a co-founder and chief technologist of Electric Sky, a company developing the ability to wirelessly transmit power to moving vehicles. He also serves as chairman of the board of the Tau Zero Foundation. I am your moderator, Stephen Ewan Cobb. I have interviewed over 400 people and written over 100 magazine articles. I produced 485 episodes of my award-winning podcast, The Future and You. I am a futurist, transhumanist, artist, essayist, and I am on the advisory board of the Lifeboat Foundation. Pulled 2 pages instead of 1. Our topic for this panel is disruptive space technologies. The definition of a disruptive technology is one that supplants a previous technology. Cell phones replace landlines. Digital cameras will replace the old chemically based film cameras. There have been a number of disruptive technologies involving space. The development of communication satellites was disruptive because it allowed us to send radio and video images around the world in just 1 or 2 jumps. It was a massive improvement in speed. I've assembled a list of about 20 disruptive space technologies to spark conversation, but I'm sure each of our guests has some technologies they want to bring up. So let's start with theirs. Each of you, if you would, take about a minute or 2 to describe what disruptive space technology you feel is important. What have we done? What are we doing? And what do you feel we need to do? Beginning with LibertyCon's science guest of honor, Art Dula.
Thank you, Steve. First of all, I am very proud to be part of LibertyCon. I'm a patent attorney, not a scientist. So to be a chief scientist, I got to write to both of my 2 sons about that and brag. So
thanks.
Okay. Disruptive technology, from the viewpoint of a patent attorney anyway, is something that nobody believes. It's not just something that's a linear change. It's an exponential change that makes something possible that wasn't really possible before in the way that it is possible now. You gave a couple of examples, and certainly there are hundreds. In space, we're still in the early stages of space. We're still shooting fire out of one end of a stick to get the other end of the stick to move. And in space, we can look up, we can look down, and we can do about 5 different kinds of science experiments, and we can live there. That's pretty much it. I personally know of about 4 technologies that I know about because I've written patent applications on them that I'll share with the people at LibertyCon. One is a way of looking up into space and down at the Earth that doesn't use lenses or mirrors to focus. It uses an algorithm and it works. And if we make it work, it would cost less than 1% of conventional precision optics telescopes. You can see the uses it might have in science and in espionage.
Mhm.
Another is a way to get back from space that doesn't require you to turn into a fireball. And this is a really simple invention, but it turns out that nobody ever really found a way to do it before. It's a variation on skip entry, where, like skipping a stone across water, you take all the energy out of the stone and then it sinks. Now, the Chinese have used it twice coming back from the moon. And it was an alternative to the way to come back for Apollo, but it was deemed to be too dangerous. If this works, it would pull more than 95% of the reentry thermal and mechanical load off of the reentering spacecraft. I think you can see how that could be important.
Mhm.
The third one is completely crazy. There may be ways of coupling into the structure of space-time. And people are starting to find out about that now. And I'm sure Jeff can talk about it more than I can. But those are the ones I know about. And I'm sure there are thousands that I don't know about.
Mm-hmm. Speaking of Jeff, do you want to comment on that a bit, as well as then bring up yours that you want to talk about?
I don't want to comment on that, but
Okay, that's fine.
I will roll into the others.
Okay.
So I wear two hats at LSky and Tau Zero Foundation. LSky is pretty much trying to develop a way to make chemical rockets obsolete for Earth orbit transportation by leaving the power supply on the ground instead of carrying it with you in the form of chemical propellants, which can let you get to orbit with a vehicle that's about 10 times smaller to do the same job. And electricity is about as cheap as energy can get. It's a very challenging prospect, but reusable rockets, which I've worked in my whole career, depend on the assumption of a very large market materializing and to have a lot of traffic. Right now, there's not a lot of sign of that happening. So beam propulsion is an attempt to say, how can we get to space cheap if we don't first start with a very large transportation market? And then in the deep space arena, I've been progressively more intrigued over the last 10 or 15 years by the uses of space plasmas for propulsion. The solar wind being the most obvious of those. If the audience doesn't know, the solar wind blows pretty fast, about 80 astronomical units per year in the plane of the ecliptic. So if we can get up to those kinds of speeds and use that free energy of the wind out that's already there for propulsion, you can achieve some pretty dramatic effects. And that's got uses in the Earth-Moon system. It's got uses for fast transits to the outer solar system. I've done some work, and I'm continuing to do some work on harvesting it for energy rather than for momentum, so that you can stop and turn around and come back into the inner solar system. And it's got implications that I've talked about at some past IRG events for at least some portion of the propulsion problem for interstellar flight. So there's a lot to do, and it's really surprising, I think, to a lot of people how little sources of funding there are for this kind of work. The amount of funding it would take to start demonstrating some of these things in space is just not that large. So those are areas ripe for disruption.
Okay. Les, if you would, you're pretty knowledgeable, so to speak, about solar sails. Would you go next, please?
Sure, and given my virtual background, right?
Yeah, tell me about it.
Well, yeah, I've spent most of my career working in what I consider to be some of the disruptive space propulsion technologies. I started out working on an electrodynamic tether propulsion system, which basically steals energy from the Earth's magnetic field to drive thrust around a planet. There have been a couple of flights demonstrating that. That hasn't really, no pun intended, taken off for mission use yet, but I think it's revolutionary, especially for visiting planets like Jupiter, where you could generate megawatts of power and do all the maneuvering and essentially use no fuel. So that's one thing. I'm currently involved in solar sails, and I know Jeff's a big fan of sails. He's looking at the plasma. I'm looking at sunlight. I think we're going to see a revolution. We fly the Near-Earth Asteroid Scout solar sail this fall in November for an interplanetary mission. And then the one picture behind me is supposed to fly in 25, and that's called Solar Cruiser. And that'll be an 18,000 square foot solar sail that'll be demonstrated. But that's all stuff that we're doing now. When I think of disruption for space and space exploration, there are a couple of things that have been demonstrated and are in the pipeline. One is optical communications. That, it gives you all the benefits of like fiber optic to your home for internet, but for deep space communications, which is huge, for getting data back across the solar system, which right now, if you go out to Pluto, it took the New Horizons mission a year at low data rates to get all their pictures back from Pluto. Once we have an optical comm system, we can be doing essentially high bandwidth broadband all over the solar system, which is pretty cool. I've got a whole list of them. Additive manufacturing. I really believe that when we've got our first self-sufficient settlement on the moon, two things will have enabled it. One is rockets, and the other is the ability to make all their spare parts in situ where they are with additive manufacturing. So the list goes on. There are so many things that are in the pipeline that you just change everything, at least in the near to midterm horizon. And I'm really eager to hear what some of my other panelists have to say about even farther term stuff.
Okay, Stephen, would you take it next, please?
And like the previous speakers, I came in armed with a list. I won't go through all of it.
I probably won't even get to my questions.
Yeah, 5 years ago, as Jeff and I were working together on a previous project, I would have said the most important disruptive technology was reusable, cheap launch. It looks like not only has that been demonstrated, dozens, maybe 100 times now, but companies other than SpaceX are getting that religion. So I don't think I need to say that's a disruptive technology. That's just the way things are going to go now. In terms of something disruptive, as I've stolen a line from Jeff, is space is radioactive. So it's actually a really good place to use nuclear propulsion. I don't necessarily want to launch from the ground using it, but once you're in orbit, nuclear propulsion makes an awful lot of sense for not just interplanet missions, but outer planets. And there's work going back to the 1960s. We stopped doing that. We need to start doing that again. Les, I think that's going to be the next 50 years of Marshall Space Flight Center is building in-space nuclear propulsion. And I want to see that happen. In terms of the optical comms, it probably is not as disruptive to the business of space as we like to think of it, but it could be disruptive in the fact that it could mean a lot of money for us. One application of optical comms, which relates to my day job at the University of Arizona, is using satellite communications for quantum key distribution and actually sending entangled photons from a satellite to two Earth stations at widely separate points, like transcontinental or intercontinental. That's worth quite a bit. And there's a lot of work at NASA and elsewhere on doing entanglement as a service through satellites. The last thing I want to mention is, again, back to the 60s with Gemini and Agena, we demonstrated tethers for rotating objects to demonstrate artificial gravity in a very, very small application, and we never did it again. If we're going to be sending people out for a long ways, we have learned that sadly Robert Heinlein was wrong. I'm sorry, Art. Zero gravity is not good for us. We're not going to live for 200 years by being in a space station, and we need gravity. We don't know how much yet, and so there are proposals for free-flying centrifuges where we can measure different levels of gravitational effect on initially probably mice, but eventually people. And let's see what 1/6 gravity does to us long term. Let's see what 1/3 does. Let's see what other ranges can do. And that's something which, if we're talking about putting large numbers of people in space for long periods of time, we're not going to put them in zero G. So we're going to have to figure out some sort of rotating structure, and that will be a disruptive technology for human exploitation of space.
Okay.
I have others, but I'll stop.
Okay. Joe, if you would comment a couple of them.
Yeah, sure, absolutely. So I come at the disruption from a little bit of a different angle from most of the other presenters here. During my day job, I'm actually a materials scientist, and all of the things that we've talked about so far here today, with the exception of the quantum communications, all of these technologies are made out of stuff. And so we need to figure out what the stuff is necessarily going to be to make all of these disruptions possible. I appreciate Les bringing up the additive manufacturing aspect. In fact, where I work at Savannah River National Laboratory, I actually have the opportunity to work at some of the really cutting edge of additive manufacturing. And I'm excited to see how we'll be able to eventually bring these new types of materials to the challenges that are going to address humanity expanding into space. But one of the things that I'm interested to see a little bit more come about is in the metamaterials and metasurfaces disruptions. So you can think of these materials as patterns, okay? So metamaterials are three-dimensional structures that have a structured pattern within them. Metasurfaces are two-dimensional patterns that spread out across just a single surface. And the way that these patterns are constructed impart particular properties onto whatever wave is interacting with this metasurface. So you can make a metasurface for sound waves, you can make a metasurface for optical or IR waves, and that is going to allow researchers and scientists and engineers to eventually be able to control waves of different types that aren't allowed by current lensing technology. So this allows us to move to large area, lightweight communication systems. For example, it'll allow us, possibly to bring solar sails or plasma sails to whole new ranges. So I'm excited to see where metamaterials and metasurfaces are going to lead.
Okay. Doug, if you would present some of yours.
Les hit on something when he talked about in situ resource utilization. That goes to the asteroid mining that we're seeing a couple of companies talking about doing, but nobody's actually done any test missions so far. But there's one other aspect that occurred to me when we were at Wichita, and there's a lot of junk floating around our planet in orbit. There are different groups talking about figuring out ways to capture space debris and deorbit it, but that's a feedstock. If you're going to do in situ resource utilization, you got the resources waiting right there to be disassembled and reused. If somebody can come up with a way to use that material as a feedstock, you've already got it in orbit. You don't have to spend anything to get it there. This could be a very disruptive technology, I think.
Interesting idea.
If the company said, you want a communication satellite? Fine. Here are the modules we can provide. We will just assemble one for you, pay for it.
Okay. Yeah.
A couple of other disruptive technologies, if I may. My purview is more interstellar than in system. So these are a little farther out. Michael Hipke has a series of papers on quantum communications between stars. If any of what he is thinking about and talking about actually comes to fruition, we may look at much higher data rates coming back from interstellar probes than anyone had thought possible.
Okay.
The last one I've been following, everyone's heard of the Alcubierre warp theories. Alcubierre was the first one. Those are not the only warp theories. There's been a lot of study going on. One of the big problems with Alcubierre's theory was it required massive amounts of negative energy, which nobody has ever seen in reality. The latest theories are going to much lower amounts and total positive energy warp fields. So this is not really a technology just now, but it's a theory moving towards technological possibility. And if we could get a warp field that can actually be demonstrated at work, that right there is about as disruptive as it gets. Now,
Yeah.
I should also mention, people hear warp field and they think faster than light. Those are two different things. You can have a warp field that is limited to the speed of light, according to some of the theories I've seen. That may make people unhappy that you're not going to Star Trek it all over the place. But still, if you're moving at the speed of light, that's not shabby.
Yeah, yeah. Ken, do you have one or a couple?
Oh, yeah. Well, as a general statement, any new technology is going to be disruptive to a greater or lesser extent, and disruptive in ways that are hard to predict. The invention of the automobile with its back seat changed the dating habits of an entire generation. And that was totally unexpected. And you're going to see a lot of that. Yeah. Space technology is going to require a lot of innovation. It's going to require a lot of new technologies. It's going to be very disruptive to the Earth power structures and economic systems in ways that are hard to predict. A couple of technologies specifically that haven't been mentioned: AI, the artificial intelligence. Again, that's going to be disruptive in ways that no one can really predict at this point. There's also a field, IA, intelligence augmented, where humans use machines to become more intelligent. Again, that's going to be extremely disruptive. Energy, if we come up with a good fusion drive, concentrated sources of energy, wow, that's going to be disruptive. Being able to move and harvest asteroids is going to be extremely disruptive. Suddenly we have tremendous quantities of silver, gold, uranium, rare earths that quantities that we can't even begin to dream of now are going to be available once we start harvesting the asteroids. So there's disruptions coming if we get into space. And if you're part of the ruling elites, maybe you don't want people to go into space because it will be disruptive.
Yeah, when gold is as common as pebbles in a stream, yeah, that's economically disruptive. The price of gold could drop to basically the price of water.
That's right. That's right.
Yeah. Does anybody have anything that we have not yet mentioned? Any disruptive? Anybody?
Well, actually, since you mentioned, go ahead, Stephen.
Since no one has really touched on the life sciences part, I feel obligated to mention that better closed loop life support systems are something which lots of people are working on. We actually have got a full seminar on that at the Interstellar Research Group symposium here in Tucson in September, which I hope you all come to. But getting from 95% to 99.9% reuse of particularly of water in a closed setting, that's going to be critical to doing lunar bases. It's going to be critical to doing Mars missions, any sort of deep space missions. We can resupply low Earth orbit from the ground if we have to, but once you're past Mars orbit, you better be working with what you got with you. And,
before we go to Joe, you mentioned a symposium. How would somebody find out more about that? Like if they want to attend or whatever?
Okay, Interstellar Research Group, which several of us on this call are involved with, has a symposia every 2 years. The next one is September 24th to 27th. It's going to be here in Tucson, Arizona. It's going to be awesome. You should please try to make it as part of your schedule. And you go to IRG. It's Indigo Romeo Golf .space, and there should be a big green button that says register now. And so press that big green button.
Okay. Thank you. Joe?
Yeah, actually, since you mentioned water as a resource versus the price of gold, I mean, even if we have nearly perfect water recovery and resource recovery, there's always going to be some intrinsic loss to a system. And so the discovery and access to water in deep space, being able to map that distribution within our solar system, between individual solar systems, that's going to be an important piece of information in determining the stepping stones that we're going to take to the stars.
Mm-hmm. One of
I
the
just want to throw in something too about the biosciences, and
Sure.
this will kind of reveal my age, right? There's a famous movie, I was actually a little young for it, called The Graduate, where there's a statement in there, you know, the future is in plastics, right?
Yeah.
The future is in biotechnology. I firmly believe that we're in the middle of the biotechnology century. Last century was the century of physics, which caused me to study physics and do what I do. But I think in this generation, in this next 80 years, we're going to see breakthroughs in the human-machine interface. We're going to see engineering of the human genome. I wouldn't be at all surprised, Stephen, if there's a rival to artificial gravity in space, and that will be some kind of virus targeted to cure osteoporosis and help stop the bone loss in astronauts and muscle loss through active genetic engineering. I think that's coming.
That's another way of solving the problem. Which, yeah, that could win. That could win. Then of course we're diverging the speciation of humans a little bit, but there's lots of room for development.
Doug, you have something?
Now that everyone's talking about biotechnology, I just read a news article this morning, I think from UPI, about a group that has genetically modified E. coli to be able to express one of the shell proteins from the COVID-19 virus. Said we should then be able to culture these modified E. coli, kill them, and use them as a vaccine. They said the particular shell protein that they have is not unique to COVID-19. It's common to all coronaviruses. They said this vaccine may be a broad spectrum vaccine for all, like 25% of cold viruses in addition to COVID and other coronaviruses.
And you're talking about using it as a means of transport for drugs and such?
Well, not just that. What it is the E. coli genome is probably the best known genome of any organism on the planet. It is very well understood. The bioengineers know exactly how to modify it. If they can come up with genetically modified E. coli, they should make vaccine creation and broad spectrum vaccines much simpler. But the other thing is the whole 10 years ago, it took a giant laboratory and they would have maybe a 50-50 chance of getting something to work accurately. Now, a genetically, what should I say, the laboratory system necessary to do these genetic modifications is about the size of a desk, and it's about 95% accurate. As technology goes, if it's going to get down to something the size of a filing cabinet, and any high school science lab can have it, gee, anyone can make genetically modified E. coli and infect stuff. That can be about as disruptive as anything, and not necessarily for a good way.
That's one of the most terrifying things I've ever heard, Doug. Thank you.
Yeah. Ken, you have something?
Yeah, I'm sure, you know, someone in the audience heard our comments about mining asteroids and suddenly gold becomes worthless. And they probably jumped to the conclusion, well, okay, I'm going to buy cryptocurrencies. Well, quantum computing is one thing we haven't mentioned about, but it's got the potential to break a blockchain and make, you know, what Bitcoin and whatnot pretty much worthless. So don't think you have a safe place to put your money just yet.
Yeah. A few years ago, I interviewed my nephew, who's an IT professional. He works in IT security. And I asked him if these quantum computers are so good at breaking crypto, won't they reach a point where all of the crypto people are relying on to protect their bank account and their Bitcoin and stuff like that, that they'll all be breakable like in an hour? I mean, and he said, oh yeah, that'll happen. And it's like, he said it like a big shrug, like it's obvious. Yeah, so that's definitely disruptive. That's like the definition of disruptive. Jeff?
There are good reasons why people are working so hard on quantum cryptography, and it's because it's the race to have the replacement in place by the time that solution no longer works.
Okay, yeah. Well, let's wish him luck, because I own a little bit of Bitcoin. One thing nobody mentioned, although they did mention asteroidal mining, I didn't actually hear anybody mention the possibility of mining ice on the lunar South Pole, which was theoretical in the 90s that it would exist, and then of course Clementine verified it, the orbital probe. Does anybody have any thoughts on that? I mean, if there's water ice there, it could be, you could split it with electricity from photocells, and then you could use it to breathe, of course, because water is composed of hydrogen and oxygen, and you can use it as a fuel, allow it to recombine in the rocket engine back into water as a propulsion. Does anybody have any thoughts about that?
And just one more, although regolith is handy, it also makes a decent radiation shield for your vehicle. So there's lots of uses of water. And look, I'm a much bigger fan of mining water, whether it's from the moon or from comets or from wherever, than I am of mining gold and platinum and rare earths and what have you. I think water has got a lot of reasons to be acquired in situ, or in situ. I can't pronounce it. The issue has become at this point, we've done enough remote observation to prove that it's there, but we don't know what form it's in. Is it lying there as a block of ice? Is it thoroughly mixed with this horribly nasty sharp-edged lunar dust, which destroys machinery? Is it in some other form? And so the Viper mission is going, is it next year? Not too far from now, to go actually take a look at some of this. But there's a lot of good solid engineering work that has to be done, going from the scientific knowledge that there is water at the South Pole, yay, to here's a liter bottle of water which was extracted from that resource. And some of that work can be done on Earth, and some of that is happening at many universities around the country right now. Some of it will have to be done on site, probably robotically, eventually with humans in the loop. And that's expensive. That's going to be, that first liter of water is going to be very, very expensive. Hopefully liters 2 through N get a lot cheaper.
Okay. One innovative technology.
Yeah, Jeff wants to chime in on that, I think.
Oh, I'm sorry. Go ahead, Jeff.
I just wanted to, it's easy to talk about gold or platinum or water, and those are important. And the reason they're important is that what really matters is the industrial development of space, which is a complete, the ability to make stuff there, without getting wrapped around the axle about just which kind of stuff will come first. The importance of any of these individual resources is that you can make a case that it might be worth getting that one first. But the nature of whether it be asteroidal or lunar mining is that once you have a mining infrastructure set up and a fabrication and transportation system set up, the incremental cost for adding the second and third and fourth product is tiny compared to the cost of getting the infrastructure set up in the first place. So in essence, once you can make anything in space from space materials, you can damn near make everything. Because the incremental cost of adding aluminum and glass and copper and insulators and motors is very small compared to what it costs to get the first supply chain created. So it's not, the water is important, the gold is important, the platinum is important, but it's not about the water, the platinum, and the gold. It's about standing up the economic infrastructure.
Okay.
Steve,
Yeah.
this is Art Dula again.
Okay, go ahead.
I'm going to put on my space lawyer hat for a minute.
Okay.
All these disruptive technologies have to be capable of being done, not only from a technical sense, but also from a legal and regulatory sense. And in many ways, the legal and regulatory environment shapes what comes out of it. We had a couple of things happen in the past 5 years that are just absolutely groundbreaking. One is there was a federal law passed that says that American citizens and corporations, American entities, can own resources derived from space, these in situ resources. There was a big debate about that. It's not a debate anymore. A European country has also adopted similar laws. And the Artemis Accords, which NASA is putting forward as an international standard, recognize that we're going to have to own and have markets. Now, when you have markets, as Jeff pointed out, there's no customers up there now, except some communication stuff and remote sensing that looks down at the Earth and some scientific research, which is hideously underfunded. But if you let, as Abraham Lincoln said, if you put the, I think it was the fire of genius to the, I don't know, the wood pile of resources, you're going to get something like the United States. And that has to happen. I mean, one thing about the future is that you cannot predict what it will actually look like because so many people's interests are different. And once people get into space by thousands or millions, Mr. Bezos is correct, they're going to make their own laws. They're going to own the material up there. And I certainly hope they'll share some of it with us. I think one really disruptive technology would be to figure out how to make a profit out of some of this stuff that isn't just communications or observation.
Let me ask you, since you are specifically a space lawyer, if a company makes something that's under patent and they make it in Earth orbit and they sell it on Earth, they're breaking the law. But if they don't bring it to Earth, are they still breaking the law?
That's not accurate.
Okay.
Several years ago, the patent law of the United States is covered by 35 United States Code. It's a particular section of the US federal law. And a few years ago, the jurisdiction for patent purposes was extended to outer space, the same as it is on a US flagged ship or a US flagged aircraft. It's federal law. I can tell you there's quite a distinct and interesting conflict now between federal and state law in this area, not in patents, but in damages when things blow up. But generally, if something is on the US register, which is maintained by the State Department, and all US spacecraft are, then US law applies to it. But if it's on the Russian register, hey, and if it's on the, the perhaps Portuguese register, so you can kind of shop for your law at this point.
Okay. Well, let me ask you another question before I go to Doug. And that is, if, because the Chinese have announced they're going to go to the moon, they've announced that years ago. And they've been making steps toward that direction, baby steps, I guess, but they're still steps. Anyway, their intention is to land on the moon. And they have said that they want to use the resources of the moon. And they have not specifically said they're going to go after the ice at the South Pole that are in the shaded valleys that have not seen sunlight for billions of years, where water could get there and stay in ice form. Anyway, if they were to land a spacecraft in one of those valleys that has ice in the southern South Pole of the moon, how much land can they claim? Can they claim 1 mile around it? Can they claim the entire south end of the moon? Can they? Is there even a limit to their claim?
That's a very interesting question. Now, the Heinlein Trust has worked with the Chinese Space Agency for 10 years now. We do things with them.
Okay.
And I've had their lunar people tell me that they wanted to name their first rover Prospector because they're going after resources. And they may not have told anybody officially that they're going to go after the ice at the South Pole, but they certainly have said publicly that they're going to the South Pole. And they just launched the first element of a space station. They're building a Long March 9 that's about the size of a Saturn V. Let me mention one other thing that I think we're getting close to, but another panel member will have to take this one. I love space elevators. Pardon me, I pounded on my desk.
Looks like you're about to take one.
Yeah, no. How close, does anybody know how close we are to the materials science to build a space elevator?
That sounds like Joe Meany or Les Johnson.
You got to ask which celestial body you're trying to build it on. If you're trying to build it on the moon, we can do it right now.
Oh, okay.
Oh, well, a lunar elevator. Yeah, you can do that with, I guess, a strong rope. But I mean the Earth. I mean off of the Earth to get that cheap launch that Jeff was talking about that you have to have.
I think there's a problem that has to be dealt with before we do that, Art, and that's called the orbital debris problem, because there are 500,000 pieces of junk traveling around the Earth at 8 kilometers a second, and everything in orbit's going to cross the plane of that elevator at some point.
Yeah.
Small but finite chance every time it whizzes around the planet, it's going to turn that elevator into Swiss cheese. Yeah. So I think we're going to have to deal with that. And then there's the problem of ComSats and them running into, I don't know. I'm not very bullish on there ever being a practical space elevator materials or not at the Earth. Okay. Now at the moon or somewhere else, absolutely. I think we could and should do that. But on the Earth, there are a lot of problems. I'm not trying to be negative. I just am skeptical.
Doug, you got the floor.
This comment feeds right into what I was going to ask. That's a question of dead satellites and salvage law.
That one I can answer. That one I can answer. Because under our current international regime, as expressed in the Outer Space Treaty of 1967 and the 4 treaties that came out of it, a nation doesn't lose jurisdiction over a space object just because just because time has passed. It's not like a wreck on the bottom of the ocean. There's a lot of litigation about that. So the first satellite that was launched that's still up there, I think it's Explorer 3, the US Explorer 3. It still belongs to the US government. And there isn't anything like space salvage. You're going to have the permission of the owner of the goods to get them. On the other hand, I happen to know that Lockheed Martin would be quite happy to sell you upper stages at a great discount, providing they're used. No, I say that because I've negotiated with them on it. It's a feedstock. Hopefully, all this debris will be cleaned up because it's valuable. Look, who's going to be the first lawyer in space? That's what I want to know.
Do we need to launch into the spaceship?
Well, the problem is I'm not sure you'd care much about having life support on that.
Or re-entry system.
Yeah. Does anybody else have any legal questions for Art? It's an unusual resource. We have a lawyer on the panel.
And I think of myself as an in situ resource.
By the way, when you talk about ownership, you're not just talking about the ownership that is their right that they've got. They also have the liability of ownership.
Yes, that's very true.
Yeah.
But yet the treaty we have on liability has never been utilized. The only thing it's done has been to keep businesses from investing money in commercial space. And frankly, that's why these international treaties were set up. It was a Faustian compromise during the Cold War between the United States and the Soviet Union. The US was afraid Russia would claim the moon, Soviet Union would claim the moon. And the Russians were afraid that the evil of capitalism would go into this new pristine Soviet environment. It's a very interesting and somewhat platonic fallacy that the current law can continue. It has to be replaced. If we don't replace it, the people who go into space will.
Okay. I was afraid for a long time that that space was going to end up being like Antarctica, where no nation is allowed to own any of it. They're allowed to put bases there for research purposes, but they're not allowed to own it or to extract resources or make any valuable use out of it.
Steve, that is a real worry because there are powerful forces in the world that want to do that. But the Antarctic Treaty is not acceded to by all nations. There are territorial claims all the way down to the South Pole. I mentioned Argentina and Chile. They have post offices down there. All of their maps show their countries going to the South Pole. They've taken pregnant women down there to have citizens born there.
But extreme, but I guess it's
but it actually happened.
Okay. Yeah, it's not where I'd want to be born. Steve, Jeff, you have something?
Yeah, I just wanted to emphasize two things, but on the same point. There, for historical reasons, the sort of international legal community has a high degree of overlap with people who think that markets are icky.
Or that capitalism is just evil.
Yes.
Okay.
I tried to use a less loaded word. I mean, they think that markets are a bad idea. So there really is a strong kind of, if left to their own devices, the first thing that they'll do is just try to keep things from happening, because that avoids the emergence of challenging legal problems that they'd rather not grapple with.
Okay.
The other element is, when you raised the question earlier about what kind of claims can you make on the moon, right? That wasn't answered. And the reason that wasn't answered is the question is in some sense ill-defined. You can answer the question about what kind of claims the current international legal regime of treaties permit you to make. Exactly the same way and with exactly the same force in law as you can say, what territorial claims can you make on undersea features in the South China Sea? That's a completely unambiguous question to which there was no dispute. And the answer is you can't make those claims. Guess what? People do anyway. Right? There is no international police force. There is no international court in which these things are adjudicated, or at least not one that can enforce its rulings. Ultimately, the question about what kind of territorial claims people will or can make on the moon is going to be determined by what kind of force they can back it up with.
Okay.
All law is dependent on force, Jeff. All law is dependent on force. However, the Chinese legal scholars have been writing about a concept called quasi sovereignty, by which they mean jurisdiction over an area that you control, and they're specifically speaking about the moon. The US has been talking about a exclusive or semi-exclusive safety zone. And there are actually some bills that are being considered. They haven't been introduced yet, but they've been written that would define these in US law. As US citizens, we don't obey international law. We obey US law. And the US law receives international treaty law into its body of law at the same strength as federal statutes. It does not supersede a federal statute. And a federal statute, if later passed, can supersede a treaty. So now this is different than it is in Europe, China, Russia, any civil law country. And this is a point of big contention, because Jeff's absolutely right that there are people, we're only 4% of the world in the United States. And I can tell you that there's a much bigger percentage that lives under a law where the state owns all mineral resources. Even England, the Queen of England owns the gold and silver in the ground. So it's an interesting problem we still have to work out. TBD.
Okay. We're running a little on time. We're at 5:54. Let's see if we can close this up. Roy, Ken, rather, and Joe, you guys haven't said anything in a little while. Do you guys have any closing thoughts on disruptive technologies?
Yeah, one quick comment was the military dimension for this whole topic has been kind of left out.
Yeah.
But there is a massive military dimension to space technology, and that's going to play a big role in the future.
Mm-hmm. Mm-hmm. Joe?
Yeah, I mean, I think that working together to really produce new materials for characterization here on Earth, the way that we can develop high throughput measurement systems and coupling that to machine learning techniques to discover new materials that necessarily wouldn't have drawn the interest of scientists is going to be an interesting near-term step for enabling a lot of the technologies here today. There's a lot of work being done around the United States and the world to enable AI to probe these kind of interatomic and intermolecular interactions that allow for more detailed force analysis that are going to produce some really interesting results that then once we figure out the chemistry to make these things, we'll get to create some very, very fascinating applications just coming straight out of science fiction books.
Okay. Well, thank you all for coming. It was great stuff. Okay.